right. Called this x. Probably did x over 3 equals 5 over 2. You can cross multiply. You get 2x equals 15. And then x is 7.5. How many of you just multiply both sides by 3? Awesome. Because x is on the top. Times 3 would cancel. Times 3, you'll get 15 halves, which is 7.5. So Pn is 7.5. Questions on that? All right, next is the converse. Oh, what do you think the converse is going to say? Opposite, the reverse. The hypothesis and the conclusion have switched, meaning if you end up seeing that these ratios are equal, those segments must have been parallel, right? Must have been parallel. It's the converse of the triangle proportionality theorem. It's a lot of words. A lot of words for something that's pretty simple. If AE over EB ends up being the same ratio as AF over FC, lines must have been parallel. So this is more of like a verify step. You're going to see this on the quiz next week. I just finished putting the quiz together, and on a problem like this one, it'll say show that the lines are parallel, and then it'll have an area for work. Okay, so exactly what you would need to show is that the ratios are equal. Is 10 over 15 equal to 8 over 12? I'm going to put a question mark here. A question mark above the equal sign. Are they equal? And because you guys should practice like reducing fractions. Why? Because you're going to see scale factors on the quiz. You're going to have to give the ratio between the triangles. You could put a decimal here. I would recommend writing it as a reduced fraction. Okay? That's just good practice. All right. 10 15ths reduces into 2/3. 8 12ths reduces into 2/3. They are equal. Yes. So what's our conclusion? Therefore, DE must be parallel to BC by the converse of the triangle proportionality theorem. And I'm not going to make you write that out. I'm not going to make you write out by the converse of the triangle proportionality theorem. Cal.
When is the test?
Wednesday.
Are there proofs on it?
1. Easy proof.
Oh, yeah, right.
Were any of the, well, I'm just asking you guys, were any of those similarity proofs like difficult, did you think? Oh, I just didn't correct it.
The one on the back.
Yeah.
Number 8.
Not on last night's worksheet. I'm talking the proof day, like yesterday
No.
in class, the proofs we did. All right.
So the review guide that we got yesterday, that's like the review.
That's not.
Because it doesn't have this.
I'm gonna do completely honest. No, that was only 8133. You're gonna get a quiz review on Monday or Tuesday. Sorry.
And the quiz is Wednesday.
All right. Here we go. AC, I like to label the picture. I recommend you do as well. AC is 36. Well, that is the whole thing here. BC is 27. Verify the segments are parallel. All right. Now, the converse of the triangle proportionality theorem doesn't say anything about this segment over the whole side length. We all agree it was kind of unique. It had 20 over this AD equals 15 over BE, right? Well, if you know the whole thing, you guys can figure out what's AD. If 36 is the whole thing, this part's 20 by the segment addition postulate. This part's 16. And this part is 12. And there's your parts that you can set up with proportions. 20 over 16 equals with a question mark. We're trying to show, verify, equals 15 over 12. 20/16 reduces into 5/4. 15/12 reduces into 5/4. They are equal. Therefore, DE parallel to AB. Have we used the three dots before?
No.
Habit, sorry. Is a mathematical symbol for therefore. Therefore. If you continue with your math education beyond high school, okay, you're going to learn a lot of symbols that are shorthand for words and proofs. Like therefore and such that and for all and element of and all this. You can write a whole sentence with symbols in math. Feel pretty nerdy. All right. If 3 or more parallel lines intersect, let's get quiet. If 3 or more parallel lines intersect 2 transversals. Okay, so hypothesis, there are 3 or more parallel lines intersecting 2 transversals. So the hypothesis is that that's parallel to that, which is parallel to that. And they're intersecting, remember these are called transversals. Conclusion, they divide the transversals proportionally. They divide the transversals proportionally. Don't get lost in all of those words. It's not that difficult, okay? I'm going to let you finish writing that down, and I'll show you on the picture what we're really looking at here. I don't see any triangles up here yet, do you?
No.
Right? We don't get to see those transversals crossing to then make triangles, but I bet it wouldn't take too much imagination to see, like, if they're going to cross, which they're transversals, they're probably going to cross, then isn't this kind of like the proportionality theorem we just practiced? AC over CE, part over part, equals part over part. Do you guys see what I'm talking about there? Awesome. One person sees what I'm talking about. All right. So very similar. All right. Suppose that an artist decided to make a larger sketch in the trees, of the trees. In the figure, AB 4.5, BC 2.6, KL 4.9, and CD was up here 4.1. Find LM. So LM is right here. And MN to the nearest 10th of an inch. All right. Well, let's start off with this trapezoid here. Can you guys see the black trapezoid I just outlined? Why would I pick that one? Well, there's only one unknown in that one. I bet you could all see. If I looked at the trapezoid over here, I'm going to do it, see if yellow is going to show up for us. Yeah, that's not bad. If I did that one, do you agree I would have 1, 2 unknowns? You guys agree with that? I would have 2 unknowns if I started with that one. Now, I do need MN. That's going to be one I need. But I don't want to start in that one. I want to start in the black trapezoid so that I can use that proportionality theorem and say 2.6 over 4.5, 2.6 over 4.5 equals LM, you could call it X, over 4.9. Now, the main thing you should be careful of when you're doing these is that you're going in the correct order. If I go right over left, then in the other fraction, you need to go right over left. Okay, just stay in the same order. Ella.
So it doesn't matter if I put 4.5 on top and then 2.6.
What do you guys think? Could if she went left over right, if she went 4.5 over 2.6, then what would you do in the other one?
4.5
4.9 over x. That'd be fine.
Okay.
The main thing is to check that your cross multiplying is going to be the same as my cross multiplying. Let's set yours up and see what happens real quick. 4.5 over 2.6 equals 4.9 over x. What are you going to multiply together? 2.6 and 4.9? What am I going to multiply together? 2.6 and 4.9? And then you're going to multiply the unknown and 4.5. 4.5 and the unknown. We're good. We're good. All right. If you use my shortcut, you're just going to be multiplying by 4.9 on both sides. So I would do 4.9 times 2.6 and then divide that by 4.5. You better get an answer for that. 39.2 sounds kind of steep. 2.8.
Okay.
Yeah, 2.83, 2. Let's see, it said nearest 10th, so 2.8 would be perfect. So LM is 2.8 inches. The drawback of calling that x would be that you're going to have to solve for two unknowns in the problem, and just be careful that your x that you're calling x is the right one, right? For each setup. All right, second part. I'm actually going to call that. Was it 2.83? Did I say? Mm-hmm. Here's my recommendation, and this will carry with you for a while. If you are doing an intermediate step in a process, always round more than what they're asking you in the final answer. Here's what I'm saying. I'm going to call that 2.83 so that it doesn't mess up my calculation when I do MN. Because what's going to happen? I rounded once. I have to round again. Have you heard of compounding rounding error? Have you ever heard of that? Compounding rounding error. Do you understand what that means by the words? If you keep rounding something over and over in repeated calculations, it's going to get worse and worse. It's going to get more. It's going to have more error. It's going to get farther off from the true value. So it's good to take it farther in the decimals along the way. And then the final answer, I would put 2. If they ask for this round of the nearest 10, I'm going to put 2.8. But when I use it in this calculation, I'm going to call it 2.83. So here we go. Let's call this, we'll call it MN. MN over, and that LM was 2.83 equals 4.1 over 2.6. Multiply both sides by 2.83. So 4.1 times 2.83, and then divide that by 2.6. I get 4.46. MN is 4.46 inches. So on my final answer blank, if they ask me to round to the nearest 10th, I would round and say 4.5 inches. And this one would be 2.8 inches. The reason I bring that up is the next chapter we're doing is called right triangle trigonometry. Have you ever heard of trigonometry? Mm-hmm. Any idea what it is? It's not that bad. It's actually my favorite chapter of the year. Okay, it's got the most application. Like it's used the most. Okay, if you're ever trying to calculate something, it'll keep you from hitting a pool if you're cutting down a tree. Trust me, I speak from experience. Did I say that story? I don't think I did.
No, you did not.
What did I do, Jackson?
Yeah, I just wanted to do.
What's the story, Jackson?
The story you cut down. Oh, maybe it was just a spot. Maybe it was just a spot.
Did he do it too?
I think he did. Yes, he did.
Jackson, you didn't know what McDonald's
I've heard that story before.
So here's the only thing. Tree. Here's the short end of it.
It could have been a dresser. Oh, but he was building the dresser.
That has nothing to do with these.
This is interesting.
They're both made out of wood.
It's just my little last stories, so.
Maybe we should just leave that one for another day. All right, we got a tree. The only thing you need to calculate the height of the tree, you don't want to climb up it with the tape measure, right? The only thing you need to calculate the height of a tree is a phone to get the angle. There's an app. You just look up and that tells you the angle and how far you are away from it. That's all. It's kind of cool with math. You all you need is the distance you are from it and an angle up to the top of it, and you can figure out how tall it is. All right, that goes for a building. It goes for anything. All right, and so if you're cutting down a tree and you don't want it to hit your house or your pool, you can actually figure it out. And we got within 5 feet of it because then we cut it down and it fell within 5 feet of our pool. It's kind of cool. I may have been on a 4-wheeler with a rope tied to it to make sure it pulled in one direction. Would not recommend that unless you know your rope is long enough. Because then it falls and you're driving this way. All right. This one's kind of weird. All right. Here's what I would say. For this one, you need to be careful that you're oriented in the right direction. Like the triangles are going to be turned, rotated, and you're going to have a couple things that are key here. It's called the triangle angle bisector theorem. All right? An angle bisector of a triangle. Let's refresh our memories. What does an angle bisector do? Bisects an angle. When you bisect an angle, you get two congruent angles. Very good. Very good. Can you see the two congruent angles in the picture? Therefore, blank is the angle bisector. What is the angle bisector in our picture? AD. Very good. Or DA. All right, let's keep going. Okay, an angle bisector of a triangle divides the opposite side. What's the opposite side? What's the opposite side from the angle that's being bisected? I heard someone say it. BC. BC is the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. What? What's going on here? Yeah, me neither. So I hope you guys understand this. Let's move on. All right. I never really got this. So.
Is this on the list?
Just kidding. I will explain that. All right. An angle, the angle that's being bisected, the angle bisector. Watch up here. I'll joke in a sec. The angle bisector divides the opposite side, BC, into two parts. Can you all see it? BD and DC. Can you see the two parts? Into two segments whose lengths are proportional to the lengths of the other two sides of the triangle. All right, it's much easier if you just look at it. Ready? Where's BD? Right here. BD over DC. So part over part. Do you agree? BD is not a side of the big triangle we're talking about. It's part of the side. Yes? Part of the side. DC is not a side of the big triangle. It's part of the side. It got created from the angle bisector. Part over part equals side over side. Now, all eyes up here. Stop what you're doing. Quit daydreaming about whatever you daydream about in math class. All right? And watch up here for a second. This is the key part. All right? It's very simple when you visualize it. First thing you have to do is draw your eyes to the angle that's being bisected. Sometimes the triangle is going to be turned like this. It doesn't matter. Okay? The opposite side. Whatever you do, stay consistent. I'm going to do left over right. BD over DC. If I do left over right, then the way I'm looking at it, I have to do the left side over the right side. Does that make sense? So left part over right part equals left side, it's the side of a triangle, over right side. Could you do right over left equals right over left? Ella asked a similar question on the last problem. Yes, as long as you stay consistent. Are you with me? Did that make any sense at all? Awesome. Let's practice it. All right, so we turn the picture on you. Okay? What's the first thing you should do? Draw your eyes to the... I would do the angle that's being bisected first. Okay? Now, I know what you guys are thinking. The next thing you do is you look across from the angle that's being bisected. Do we all agree it's going to be SR over SP equals QR over QP? I'm writing it out with symbols for the first one. Now, didn't we do left over right equals left over right? But it's turned upside down. Like, if you want to, you could be that weird person that goes like this. I'll know who you are when you're taking the quiz. Okay? You'll be the weird person going like this. Actually, no. You'll just go like this. But you know what I mean. Or when the really smart people realize, hey, you can just turn your paper. Okay? All right. Now, do we all see, if we're looking at the angle, isn't this the left part? Left part? And isn't this the right part? And again, the left and the right doesn't matter as much as that you are staying in the correct order. Do you agree? Left part over right part equals left side over right side. Do you all understand what I'm talking about? Awesome. All right. Let's go ahead and plug in what we know, solve for what we don't. SR is x plus 5. SP is x minus 2. Left side is 40. Right side, 32. What should we be careful of when we cross multiply? By the way, we have to cross multiply here. What should we be careful of? When I multiply 32 times x plus 5.
You have to put an equal sign between them. Like,
yep, we're going to need an equal sign. I agree. What else should we be careful of? McKenna? You have to distribute. So what should we put there to remind ourselves to distribute? Parentheses, right? So 32 times x plus 5. There's Christiana's equal sign. 40 times x minus 2. Would this be wrong if a student did this? X minus 2 times 40. Is that wrong? It's not wrong, but what would you be concerned that they're going to do? You can distribute backwards. I'd be concerned that they're going to forget to distribute. They're just going to do the negative 2 times 40. That would be my concern. Maybe you won't do that. I hope not. I always put my numbers out front just to be safe. We good? Here we go. Distribute. 32x plus, I believe it's 160, equals 40x minus 80. Are we good so far? Solve for x. So we're going to, I don't know if you guys moved. Were you taught to move the numbers or the x's first?
the X's.
Why is that?
Yeah, put it out of the way.
I moved the number before.
I don't care, honestly. I don't care.
You didn't listen to algebra very well, did you?
All right, so we get 160 equals 8x minus 80. Add 80. 8x equals 240. Divide by 8. Did you get 30? I did that quickly in my head, so check my work, please.
Can you just do like when it's like this? Can you just do like whatever, like this minus that to give you x? Because it's equal to each other. Why?
Coincidence.
Why?
It was just a coincidence. All right, let's make sure we answer the question. Did it say solve for x? No. It said find PS and SR. So PS is right here. What was x again? 30 minus 2. 28. SR. 30 plus 5. 35. What do you guys think? Do you understand the process? Okay. I'm going to stop there for today. I'm going to give you guys a little bit of time to start your homework. Here's the worst thing you could do is wait till Sunday night. No, I know you guys. Some of you guys. Monday morning, upstairs in that little area right above here, last minute, rushing to get the problems done. Because you're going to forget this process, okay? So I would get a good start on it soon. Let me take a look. I guess the good news is it's a 2-day lesson, and look what we have left to do on Monday. That's pretty good, right?
Yeah.
Do not write this down. Yes, do not write this down. Yes.
I'm perfectly fine with my artificial
All right. Today is day 1 homework. 2 through 6 even, 11 through 20. 11 through 20, don't complain and don't be that person that whines as soon as you see that many problems in a row until you look at it. Because there's just one diagram and it's fill in the blanks for several of them. All right. So it goes pretty quick. Get started right now. You got 6 minutes.
Can I show you my test spreadsheet?
Yeah, just 1 minute.